So in this video, we'll be starting with the PERT analysis. The PERT analysis. So these are the various nodes. We are not going to draw AOA or AON, but you can understand they have given the nodes. So this is AOA, and these are the optimist. These are the different time values which have been given. So pessimistic, optimistic, and most likely time occurred or most likely time taken to finish this particular activity. So if these values are given, how do we calculate the normal TI? Normal TI is nothing but the mean of all these things, but the mean formula differs. As you can see, they are represented as A, B, and M, straightforward formula. You need not remember the derivation of the entire formula. That is just a direct formula where you will be getting the time duration for this activity, which is TI A plus 4M plus B divided by 6. Why 6? It is the mean because 6 items have been added here. A is singular item, M is taken 4 times, and B is 1. So by 6 gives you the mean. And these which are highlighted are nothing but the critical paths. The entire path is a critical path. Critical activity, and the R is a critical path which is involved over there. 1, 2, 3, 4, 5, and 6. This, I think, in the previous video we have shown it. In my first video, I just dropped the video link in the I. You can check it. For AOA, we have actually solved this and we have found the critical part to be 1, 2, 3, 4, 5, 6. So here we are doing the PERT analysis. We are going to find out. So first see what are the questions. The first question is probability of the entire project being completed less than 23 days. Second question is what is the probability that node 4 is completed within less than 13 days. Third question is the probability to get a probability of 98 percentage, how many days will it take? Or for a 98% probability, the activity will be completed in a number of days. What is the number of days in which the activity, first the probability of its completion is 98 days. So these are the three questions we are going to answer using this PERT analysis. So for that, first we need to get the mean and the variance because we are going to use the norm dist formula here. So if you see, I'll just show you norm dist. So that is the first value. So norm dist takes the mean. If you see x, the inputs you see x, see here in the bottom, x, mean, standard deviation, and cumulative conic growth. X is nothing but this 23. Mean is what we'll be going to calculate. Then standard deviation is our sigma t. Cumulative, you can just keep it 0. So we let us get those values. So for this, just simply use the formula is equal to A means optimistic plus 4 times, or you can just go sequentially plus this again. For safety, just open the arrow brackets divided by 6. So you got the value, then simply drag it. Now you have got your mean. Then variances. The variance formula is A minus B divided by 6 whole square. Entire, even the 6 is also square. This is the formula. A minus B divided by 6 whole square. That gives you the variance of the beta distribution. So you know what is A and what is B and all. First, we'll be doing power function. The number is A minus B by 6. So A is this minus B. This part is closed, divided by 6. Now the power is 2 to the power 2. Check if we have closed the entire braces. We have opened 3 braces. We have closed 3 braces. So that is your variance. Then you simply drag it. Now, why did we highlight the critical path? Because when we are calculating the probabilities of this finishing, or when we're doing the PERT analysis, we are only concerned with the critical path because it is going to take the maximum time for finishing the project. Then what should be the mean? Mean also should be the sum of those paths, those arcs which are involved in the critical path. That is why we have highlighted it. So mean is nothing but sum of 1, 2, 2, 3, 3, 4, 4, 5, and 5, 6. That is your mean. This mean is for first question. Sigma t square. Why did I put at square? Because these values are squares. But we need to get only sigma because formula takes only sigma value. So here we will do the square root. But for here, let me just add the sum. 1, 2, that's variance. Then variance of 2, 3. Then variance of 3, 4. Then the variance of 4, 5. Then the variance of 5, 6. Then you can use math or square root, or you can also use power function. I'm using square root. That gives you the sigma value. Now come back to the question. Probability of finishing the entire project less than or equal to 23 days. The maximum time we have found for this question we have solved in the just second video. If you see, AOA is the question that we have solved. We have got 20.833. This is the critical length we have got for this activity. If you see the second video from this video, second or third, just check it. So there is we have got, this is the critical time we have got. You can think that maybe this is 100% because critical time itself is 20. So maybe 23 days are given. This is 21 if you round off. So we have 2 more days. Maybe we'll be finishing within 23 days. But that's not actually the case. We don't actually finish it in that case because this is just an estimate. This is given total time, but you don't know whether the activity will be definitely be finished in the time or not. So let us calculate its probability, which is norm.dist. This formula, second one, norm.dist. See what it is saying, what the function is saying. Returns the normal distribution for the specified mean and standard deviation. That is nothing but your probability. X is 23 for your 23 days. Mean we have calculated. Standard deviation, this one, because this is sigma square. This is sigma. Then cumulative, you can keep the distribution function to be true, 0. Cumulative, let's leave it. Yes. Just keep the cumulative to be 1. Why you keep it as 1? 1 means true cumulative distribution function. So you got the probability to be 86%, convert into percentage. 86.7%. So this is the probability of finishing the entire project within 23 days. Even though the critical length is 21, close to 21, it is not necessary the project is finished. So you might still incur penalties. Now, they are saying for node 4, only for particular node 4, they're saying probability of finishing until node 4. Node 4 means what? You'll not just finish node 4 because before starting node 4, you have to finish some more activities. So it is dependent. What they actually mean is from the start to node 4, it is finished in 13 days. What is that probability? Don't confuse that node 4 is given only for node 4. How can I calculate sigma? Should I take only node 4's value? But 4 is involved here. 3, 4 is there. 2, 4 is there. 4, 5 is there. So which should I take? That is not the case. Node 4 means until you reach node 4 on the critical path, what is the probability of finishing it in 13 days, less than 13 days? So for that, what is the mean? Mean is those paths until you reach node 4. So 1, 2 plus 2, 3 plus 3, 4. That's all because you have reached 4. No more going from 4 outside. Until 4 you reach, that is enough. So it is 12. No, not long time started. 4, 5. Equally time added. So just one error. I just added this column. I should add G column. So let me add it. 1, 2 plus 2, 3 plus 3, 4. This is done. Similarly for sigma, take the sigma 1, 2, 2, 3, then 3, 4. Again, this is sigma square and this is sigma. So square root of this number. Now again, norm.dist tab 13 days is your X. This is your mean. This is your standard deviation. This cumulative 77.6%. Just open it. Yeah. 77.6% is the percentage that until node 4, you'll be finishing it within 13 days. So if you see, the probability is reduced, which means there is a problem with node 4, or node 4 could cause you the delay before functioning the activity. Now, the interesting part. Now, until now, you are asked to calculate the probability or given days. Now they are asking, give me the days. Probability is given. So we have to use norm inverse, norm dist and norm inverse. So we have to use norm inverse. So here, if you see, there is norm dist. Below it, there is a norm inverse. See what it returns. Returns the inverse of the normal cumulative distribution for a specified mean and standard deviation. So this is what we have to select. Probability is 0.9898%. So what is the mean? What is the mean in this case? They are asking 98% probability for what? For the entire project. So what is the mean? This value becomes the mean, and this becomes your standard deviation. 24.8, which is 25 days, because there is no point days. So 25 days is the number of days. So this you have to close the decimals while you're presenting, or you can just round off in the next place saying 25. So 25 days is the time required to finish the entire project with the probability of 98. Let us check if it is true. Let us just simply for one norm dist 25 days, mean is this thing, standard deviation is this, cumulative is true, 98.3. So 98% probability that within 25 days you could finish the entire project. So that's all for project management.
Days can be in fraction.